Good afternoon, everyone. Thank you for joining our webinar. As you know, we have been in touch with your focal points, Ms. Nurjan team, for basically to understand your needs and requests for further, let's say, online capacity buildings within the context of our integrated land use planning project, ILUP project for Ayash Basin. Of course, we were hoping that we could do this type of trainings in person, as it's much more useful and also more interactive, but unfortunately, considering the situation, it was not possible so far. But not to waste any more time, and especially because our project is relatively a small project and will end in a couple of months, we didn't want to wait any further and lose any more time. That's why, with the help of our great experts, Ingrid Tasch and Cesar Garcia, we managed somehow to continue this a series of webinars online. So as you probably seen, the first webinar was already done about the ILUP concept and what we really mean by integrated land use planning, the methodologies, and how we would like to develop the scenarios, what are different parts of the integrated land use planning, and what we have done so far within the context of this project. As you probably know, we did socioeconomic analysis, we did some soil sampling with your help, and we are now waiting also for the results so we can come up with some sort of scenario development. As you probably know, this is a TCP project, and under this TCP project, which is Technical Cooperation Facility done by FAO, it is not possible to do the whole integrated land use planning methodology. So we have chosen basically two different parts of the whole plan, like socioeconomic analysis and the soil sampling, as I mentioned, to develop later on the scenarios. But anyway, these series of webinars are somehow part of also our project, and we hope that you will benefit from this online. Please feel free to ask questions. We hope that it will be an interactive discussion as well. Our experts will give their presentations, but then there will be also some time given for questions and answers. I'm sure Ingrid will explain how today's webinar is organized. I don't want to take more of your time. I just wanted to welcome you. Of course, this webinar will be later on uploaded as well online. So for those colleagues who couldn't make it today, we encourage that you send them later on the link so they can listen to the recordings. Again, thank you very much for your time, and I wish you a very fruitful webinar. So I'll give the floor to Ingrid. And I'm sorry I didn't introduce myself, but I believe most of you already know me. So just for the records again, I'm Sarah Marjani, the London Water Officer for our FAO office in Central Asia, based in Ankara for Central Asia and Turkey. Thank you, and back to you, Ingrid.
Thank you, Sarah. Thank you, everyone. My name is Ingrid Taig. I'm a FAO international consultant, and I will share my screen. There we are. Good. Okay, thank you for being here, and it's a pleasure to give this webinar. As Sarah said, this is the second webinar of 5 that we have organized. It's called Fundamentals of GIS for Land Use Planning. I don't know why this isn't, and there it is. The first one, as Sarah said, was already recorded, and the video was uploaded in FAO's webpage. It was about the methodological framework. And today we are in the second webinar, which is about using GIS for land use planning. The third webinar will be held on August 31st, It will be about Google Earth Engine as a geoprocessing tool. You will have to, I don't know if you can hear my cat, but he wants to enter, and if I don't let him in, sorry, he will be all the webinar talking. Okay, so the third webinar will be on August 31st, will be about Google Earth Engine, which is a geoprocessing cloud-based platform, really useful to obtaining a lot of information and processing information in Google's cloud. Sorry. The fourth webinar will be about land degradation neutrality indicators, using these indicators in land use planning, with a special emphasis on land productivity trends, which is one of these indicators. And the last webinar will be about using R software for analyzing spatial data and digital soil mapping. The idea of these webinars is that one builds on the other, and that after this last webinar, we will have a training on digital soil mapping, in which we will use all of these tools. So the idea is to start building on for this last training on digital soil mapping. As I said, the first webinar is already uploaded. Here is the web page in which you can find it. There are 3 videos. And the last video, the third video, which is the one that I prepared, is also an introduction for this webinar, in which I talk about all these tools. So if you already seen it, great. Okay, so today we will have 4 parts. I will start with an introduction on GIS, and then Cesar Garcia will give a practical demonstration on how to use QGIS for land use planning and working with vector data. Then I will again take the floor to give an introduction on using satellite-derived data. And finally, we will have a practical, another practical session with digital elevation models and other and different variables that can be derived from these models. So let's start. Well, I really like maps. Maps are one of the most important human inventions, and they are basic tools to explore the world, to communicate ideas, and manage our land, are really essential in land use planning. We can use maps in different stages of land use planning and to communicate ideas to stakeholders and make decisions based on maps. I found this when I was preparing this webinar, and I think it's very nice because it's in Anatolia. It's the world's oldest map is supposed to be. It's there. It's from almost 9,000 years ago, and well, you have a long history and tradition on maps, as you can see, and you probably know. And this bird eyes view that we take for granted, like now we use Google Earth, it's very different from that old map. It's a big step for human evolution, and it requires, it demands map making, formal map making requires that humans to be organized, to actually have this bird view and formal map making. Nowadays, maps are, of course, very different. They have different, for example, you can have, we have graphical scales, numerical scales, a coordinate projection system, a legend, etc. And there is a new era in cartography, which is digital mapping. And digital maps have the same functionalities of paper maps, but they have extended functionalities. And this, we can look at different areas, we can update them often, they can be interactive, etc. And this is possible because of the global positioning system, satellite network, because of computers and other technologies of the late years that have made this possible. And GIS in this context give us it's a great tool for working with different layers of information, as we can see here. And data stratification is key for ILUP and for these types of projects because we work with multi-dimensional data. And we need to analyze, compare, and visualize and manage these different layers of data. And this is something that GIS is great for. So GIS is actually more than the software. We usually refer to GIS as the software, but there is also hardware, methods, data, human resources that use them. And regarding the software, there is a question that we usually ask ourselves, and is which GIS software should we use? If you would like, maybe I will not read it now, but if you have experience in GIS and you work with a software and you can write it in the chat, I will then look at it. I probably think that if you do, you work with ArcGIS, and well, it is a great software. There are many possibilities, and you need to choose the one that is best for your objective. Some of them are more related to, are better to manage vector data, others for satellite-derived data. And we will work today with QGIS. Why? Well, because QGIS, first of all, is a free and open source GIS. It has many capabilities. It works well with vector and raster data. And there are many plugins that you can connect to QGIS. And one of them, for example, is trends.earth, which is one that we will take a look in our, not the next one, the other webinar. And with these plugins, you can do many, many things. We will look today at some plugins for multi-criteria assessment, analysis, and also for analyzing digital elevation models. So this, if you work with GIS, might be very basic, but maybe not all are familiar with these terms. So I would like to talk about this for a second. There are two data models in GIS. One is the raster and the other is vector. Spatial data has two components. One is the spatial, the position, the spatial data itself. And the other components are the attributes. So what is the difference between raster and vector data? Basically, how you, which is the data model you use for the positional information. So for raster, we use a grid. As you can see here, this is a digital elevation model of Ayash basin. And if you take a zoom in, here we can see a grid. And for each cell in the grid, we have an average value, for example, of elevation. Elevation would be the attribute. And the grid itself is the positional information. The most common format for raster images is the geotiff, is the .tiff. You get one file, which is the extension is TIFF. With vector data, in the raster data, we have a wall-to-wall approach. We have values for all the area. We have a grid that covers the whole area. But with vector, we have three basic forms for positional information: points, lines, and polygons. And the most common format for, well, points, for example, in this example, in this map, sorry, here, this is the map of Ayash, and if you can see the points with different colors, they represent the location of the sites where soil profiles were taken for this project. when, for example, lines are a collection of points, which could be rivers or roads. We will work with this data today with QGIS. And polygons represent areas. For example, I don't know, a lake could be a polygon, or an area where you know something is happening in particular. And the most common format that is used for this type of data is a shapefile. This is a type of file that comes from Esri, which is the mother of ArcGIS. But there are other formats, for example, the GeoPackage, which are more efficient than the shapefiles, but still the shapefiles are the ones that are mostly used. And as you can see here, one shapefile is actually not one file. When you have to send a shapefile to someone, you need to send many files, and you will receive many files, not only the one with the extension point SHP. You also get different files that, for example, the DBF is the database, because for each feature here, for example, for each point, and a database is associated with different attributes. For example, for each point, we could have electrical conductivity, soil organic carbon, pH, etc. And that information is in this file. You also get the projection file and many other files. So talking about projection and spatial data, I will not go very deep into this, because this is a whole, a lot of mathematical and physical information to actually understand all of this. But there are two concepts that we will see now that are very important when we manage, when we work with GIS and with the spatial data. One is that we need a geographic coordinate system to position our data. When we talk about latitude and longitude, we are using a geographic coordinate system. And for that, we need to refer these coordinates to an origin. For that, we need to represent the Earth somehow. And we know that the Earth is actually not like this. It's not a perfect sphere. For example, the radius in the equator is larger than in the poles, and it's not perfect. So there are different ways and different systems to represent the Earth. One of the most common or mostly used ones is the World Geodetic System, WGS. And it allows us to reference our geographic coordinate system. But to represent this in a map, because this is a sphere, we need to put it in a planar surface. We need to project this into a planar surface. And as you know, a sphere is not a developable surface. And it means that if you need to, this is an example of an orange. If you have to put the peel of an orange in a plane, you will distort it. So maps necessarily distort the data itself. And there are different ways to project different types of projection, of cartographic projections. And when we talk about projections, it's exactly that sense. If you see in this image, you have a lamp in the middle of the Earth, of the representation of the Earth, and you project it on different types of developable surfaces. What do I mean by developable surfaces? For example, if you use a cylinder, you can cut the cylinder here in the red line and you get a plane. So depending on the projection that you use, you will get different maps. For example, here we have the cylindrical projection, the conical projection, and the planar projection. And depending on where you place the surface is the projection you also will obtain. Why I'm talking about this? Because then we will have to use it. When we obtain maps from different sources, or when we download information from satellite information, we sometimes need to make transformations and make sure that we are doing things right. these are 3 types of projections. I think it's very nice because, for example, this is the Mercator projection, which is a cylindrical projection, and you can see here Antarctica is huge, so is Greenland. It's bigger than South America, and this is not true. Actually, South America is bigger, is larger than Greenland. So the sizes are distorted with this projection. In this other projection, the Gall-Peters projection, the sizes are relative to each other are better. As you can see, Greenland and Antarctica are so much smaller now than South America, but maybe the shapes are not so well. And I always like to show this projection. This is a planar projection because it's the one that we have in the United Nations logo, the azimuthal projection. And this is a data set, a public data set, the EPSG geodetic data set, which is used by most GIS. And here, each country and each area can have a special, for example, you have a code, for example, for Turkey is the EPSG 32637, which is, this is the datum, and this is the projection, and it is really good to make transformations. Okay. So for what are we doing for IAS and for our project and for land use planning? Well, we can use GIS to have all these different layers of biophysical parameters and variables that can help us in the process of land use planning together with stakeholders' participation. We can have land cover, land productivity trends, at the digital elevation model. We can, for example, with using GIS, calculate the area of each of the categories, as you probably know better than me. IAS is mostly covered by arable land, 40% of the area, followed by grasslands with bare area, 30%. And we are also adding other layers of information from global products, such as the FAO's Global Soil Organic Carbon. We will also obtain maps of soil characteristics from digital soil mapping, from the results of the lab. There are also many other products that are available and that are free, and we will talk about this also next webinar, that you can download, for example, using Google Earth Engine, or you can work with them in the cloud. For example, fire intensity, or urban or lights that give you an idea of of cities, and well, there are many products that could be useful. Of course, you always these are very general products, and are, when depending on the scale you are working, whether they will be useful or not. That is why it is also important to work with products at national level and at regional level and local level. And we know that Turkey has a lot of information that it could be really useful. For example, the potential forestry activities map, the certification risk map, the water erosion map of Turkey. And these products would be great to also use them for IAS and for the project and for land use planning. Okay, so how do we use this information? Well, first we have the information. How do we use it? How do we combine it? And GIS offers us the opportunity to, for example, use multi-criteria analysis. In the previous webinar, I don't know if you've seen it or not, I showed this example of this study that was published this year, and for Turkey, for Konya region, where they use different multi-criteria decision analysis techniques to make beekeeping suitability maps. What is land suitability? Is FAO defines land suitability as the fitness of a given land, of a given type of land for a defined use. So in this case, the defined use was beekeeping. So what they did, what you do with multi-criteria analysis, after you think of which is this final use of the land that I'm aiming at, you define which are the limiting factors for this. For example, for beekeeping, bees need, of course, plants. They need water, some sources of water, and once you define all these limiting factors and you have maps for each of them, in this case they use then-derived variables, topographic variables, climate variables, and many maps. You define for each criteria which is the optimal range for beekeeping. And combining them, there are many different ways to analyze the data. Basically what you do is you give a weight to each of them. You can obtain, for example, this type of maps, which are suitability maps. And here in red, we can see areas that are not suitable for beekeeping. And in green, we see areas that are very suitable for beekeeping. And this is, for example, a product that would be very useful to have for land use planning. And we can create suitability maps, for example, for forestry activities or for a special type of productive activity. Also, multi-criteria analysis is good to make analysis of decision alternatives together with stakeholders. We can analyze how different decision alternatives will turn out. Good. And well, this is something we prepared together with Soledad Bastidas, and it's very schematic. This is not true. This is, for example, one is to keep our mind towards what we are aiming at in land use planning. We need to define which areas are more appropriate for different uses, and for each of these you can use different criteria. For example, areas of permanent forests are areas where we have forests, where we do not have, where, for example, we have positive trends of land productivity, etc. Together, of course, with a participatory approach and discussions with the stakeholders. Okay, so now Cesar, I give the floor to Cesar. He will show you some activities, some practical exercise using vector data of IASH Basin. And he will give an introduction on how to download, use, and QGIS. So that is all for me now. Thank you very much. And I will stop sharing.
Okay, thank you, Ingrid. Okay, let me share my screen. And prepare here the, let me open the chat and everything. Okay. Can you see my screen? Yes. I assume yes. Okay, I will show you some things. I think I will turn off my video so you can get a better transmission of my screen. And also some web pages I want to show you, okay? I will just give a brief introduction to QGIS and also show you some example of how to open data, and we can do a bit of a simple exercise. We don't have much time, but we will do something nice, I think. So first of all, QGIS, you can search in Google or anywhere for the name, and you will be taken to this page. This is the QGIS webpage where you can download the last version of QGIS. There are different versions. I will open the changelog. So if you come to download now, you probably will find some standalone versions. So depending on your computer, most of the computer now are 64-bit. You can check that in your computer and decide which version will you download. They normally have a new version. They update it every 3 months or something like that. And then they have one version that they update once a year. So this is a more stable version. So it's a very tested version, and they put it here, and it remains the same for a whole year. And this one usually has the more different or more updated tools. This is a GIS that is open source. So normally there are different tools that you can use, but we like this very much because it's easily to teach in courses. We use it with a lot of plugins, and it's a very large community from different parts of the world. So this is, for example, this is a new version that was recently launched. You can see there are a lot of members from different institutions, educations, and research, and government. And this is just some of the new features that are in this new version. So they are growing very quickly. Every time you see a new version coming, it updates very quick. They have a lot of information and tutorial of how everything works. It's really advancing faster than you can keep track. And so it's a very good and complete software for GIS. And the good thing is free. You can download it, you can share with anyone, and you can start working right away. You can publish your data, and you don't need to pay anything. So once you download it and you open it, this is the window you will get. Perhaps some news, or if you have recent project, it will give you some of the recent projects. But for the first time, this is what you will see is very standards of many GIS. You have here in the middle the map canvas where your map and information will appear. And then you have some toolbars here with most of the commonly used tools. Just to zoom, to save the projects, open layers. We will see some of these soon. And then you have panels, a lot of different, this is a toolbox, so a lot of different toolbox here. One of the good things about QGIS is that they have their own tools, but they mostly connect to other software, like for example, GRASS, which is also one of the first free GIS that was around, Saga GIS, and then you can download a lot of different plugins and tools that they all appear here, and when you go inside, you have different sort of tools. So it's a very complete, and how you can see, there are a lot of tools and to do a lot of stuff. You also have the possibility of connecting to Python and R, so you can also program whatever you need and is missing. You can also make a model builder, so there are a lot of different possibilities. And this is also, you have these different panels here that you can configure. I always think, I always recommend, you can turn on and off. For example, if you don't like this one, you can make a space and then you can turn it on again if you want the tools at hand. But it's always good to have these two. For me, these are the main panel. This is the browser. So here is just like a file browser. I can go to my different hard drives and different folders and look for information. And here is where the layers I'm going to be opening will appear, and I can manage my layers that I'm seeing. So let's just do that to see how it works. So Ingrid told us that you can have vector layers. These are the shapefile. I'm using shapefile because it's the most common thing, and also with other software, most of the software use shapefile. But as Ingrid mentioned, there are another more efficient ways of storing vector data, like geo packages.
Can I interrupt you? Can you put that, because we cannot see the maybe a bigger resolution, we cannot read anything. It is too small.
Okay. No, I don't think I can.
No? Okay.
Put it with oh, I don't know how I can do it.
Don't worry, sorry.
Perhaps changing the resolution of the screen. Yeah, we can give it a shot. Let me see. Now, did it change?
Not much.
No, it got bigger here, but it didn't change there. Let me see if I choose. Something like this.
Yeah, there I can see it better. Thank you.
Okay. Good. Now this is too big for me. But so here we have some shapefiles and some raster files. You can see this is a logo of a vector and a raster. And as I mentioned before, this is the browser, so I can go to any folder. For example, I have this one for the webinar, AS data, and I can just get, for example, this is a soil map. I can just double click and it appears. I can also, for example, if I have here my folder, let me see, I think it's in the other screen, yes. I can bring it here, and for example, if I want to close this layer, I can just remove it from here. I can also come to here and add the same layer just by dragging and dropping the shapefile inside. You see, it opened the same file, but it changed the color. So most of the GIS software has this functionality. When you open a file, what you opening is the different elements and the different geometries. In this case, these are polygons. And they normally open with a random color, unless you already specify somewhere in the file some particular style. It will open like that. And there are multiple ways to open files. You can also come here. This is the main file opening window. You can open vector, raster, mesh, text files delimited by comma or any other differentiation. You can open geo packages, different sort of layers, virtual layers, layers that are in the internet, in different type of servers. Everything can be opened from this data source manager. But the easier is, of course, coming to the folder where you have the data, you just double click, or you can also, for example, this is the land cover, drag and drop, and it will also be opening. So what do we do now that we started open layers? So the first thing I see now is that land cover is the last layer I see. and it open on top of the other. I can change the order of what I see just by moving this one on top of the other. So this is a nice here, so it's like you are looking from the top. So first you are looking at land cover and then to soil, but because one is covering the other, you can see only one. So let's, for example, come to the soil one, which has lesser units. And you can do some of the first things you do normally when you open a layer is to explore the layer, what this layer contains, what information. So here, if you do a right click, or also if you double click on this name, you will be taken to the same place, which is the layer properties. Layer properties have information about this layer, so the name is IAS soil, is a SRI shapefile, is a multi-polygon layer, and it gives you some other data sources, also tells you which is the coordinate reference system. So this is projected in UTM, and here in symbology, labels, you can change and you can see and you can do a lot of actions. So for example, layer properties, this symbology is the representation here on my map. There are different things I can do here. I can just, I don't know, change the color if I like, something like this. I can also decide which is the color of the lines, the fill, and I also have different possibilities. For example, I can do categorize. Categorize, it will mean I will give to every polygon a color depending on a category. So which is the category? Here is value. Let me see what we have. Okay, we have VGT and area. These are two things that I have to choose. I will choose VGT, classify, and these are different soil types, for example. So every soil type gets a different color. I can change this color if I don't like the orange. I can double click. It will open yet another window, and I can say, okay, this one, instead of orange, I want a bit more red. And there you go. And with that, I change the color of the different elements with a property in the database. So like Ingrid mentioned, every of these polygons here is associated to a database. Where is the database? Well, if you right click on the name again, you can go to this open attribute table. And this open attribute table will take us to the, let me make it smaller, will take us to the attribute table. So I have 442 polygons, and as I can see, for most of these polygons, I have these two fields. One is the name of the soil, and the other is the area of that polygon. So here is the information that I can use for these layers. We will see more examples later. And I have some tools here where I can zoom in, zoom out, but I can also move with my mouse. If I move the wheel of the mouse forward, I can just make a little bit of a zoom in, and I can use these tools. If you see, every time I stop in a tool, it will tell me a little bit of what this tool does. So a bit of context information. This one, it's called identify features. So if I click on this one, and then I click here, it will automatically open another window, which will contain information on this polygon. So for this case, it's a soil type B, and this is the area. If I click this one, it will be a soil type A, and this is the area. So as you can see, every figure is associated to some database where you have a lot of information. So that's the basic concept of vector layers in a GIS system. So let me turn off this one. And you can see I still have selected, I can still select because I'm on this layer, I am on the selecting tool. So if I want this to stop, I can come and grab the hand, and now I can move and nothing gets selected. This can be closed. Let me see then the other layer that I have. No, just click here. This is the land cover. We can see what information we have here. We can go to the open attribute, and we will see this is a bigger attribute table. It has 21,463 small polygons for this area. And they have different things. They have ID, they have different codes. This is a land cover code. And then here are the land cover categories. These are in Turkish. And here are some land cover categories, some names in English. So all of the information that I have here, I can use for something. I can filter and select depending on the area, on the type of land cover. And we will do in a little bit an exercise about this. So I can also do the same and give some color to this layer. If I double click, I can come to symbology, and I can also color by giving a different color to every land cover. I can do like this. Come here, where is the name of the land cover, classify, and every land cover will be given a different color. So here you have, it's a bit ugly. Other thing you can do here is, for example, you can turn on and off any category. So if you are interested in seeing one category or not seeing one category, you can one by one put them on and off. So there was a possibility we didn't have before, but now that we categorize it with the land cover, I can choose what I want to see. If instead of land cover, I choose another of the layers, I can also do another of the fields in the database, I can also do the same. You can also have prepared styles, sorry. So here I already, once you change the color, you adjust the name, everything, you can save these styles to use later. That is what I did, and now I can load a style that I already prepared for this layer. So if I come here, I can come to AS data and load this style that I already prepared, load the style, and you see it will change to the coloring I make. So now the map looks a bit better, at least for me. Maybe too pink still. But as you can see, I put arable lands in different tones of yellow. Then you have all the different type of grasslands in different tone of pink, artificial in red, some blue for water, some permanent crops are in this type of green, and in very dark green is the forest. So we can zoom in a little bit and explore the data. And also, if you use this tool, you can come and check for every polygon what is the information that we have. We have this different sort of information, and for every of these polygons. Good. Let me zoom out again, and let me open yet another layer. Another of the layers I have here is the study area. So this is our study area. I can put this probably on top. And I can use, for example, do a simple fill, just put a transparent fill and a surrounding line. So everything you can do here is very personalized. You can change mostly everything about this data. And I will open now the road information. So this is another layer. Ingrid mentioned that there were different type of layers. There were polygons, mostly what we've been using. And this, as you can see, is different. This is a line. So this layer is made of lines. And these are the roads. I probably can put this into a darker color, black. Okay. And here we have the roads. Where are these roads being taken from? Okay, this is also something interesting. You can get a lot of different information from different sources. I took these roads, so we've been seeing this. I took this road from OpenStreetMap. OpenStreetMap is similar to Google Earth. It has a lot of, sorry, from Google Map, it has a lot of information about the different things, the roads, different features that you can find in a map. And you can download from different sites. For example, here, you can, if it is something very small, you can export it directly from here. But there are another interesting places, like this is the GeoFabric, is a repository. You can upload information from whole Europe. Or here by country, you can also download a lot of information about in different format, in shapefile or in different databases for the whole Turkey. Or you can use also this Overpass Turbo is another option that is there. Here you can build queries to the database they have. So for example, here I put Turkey and I ask for the administrative level boundaries, level 4. So this is what I get. And I can just download only this. So there is a lot of information here. You can just go to OpenStreetMap and you will be able, from there, you will be referred to these different possibilities depending on what you want to do. There are some tutorials around that will teach you how to download information. And basically you can get roadmaps, boundary, a lot of information. So, okay, now we have a lot of data here. We have a land cover, we have our study area, we have roads. So I will make a very just short exercise to show you some of the very quick and simple functionalities. This is a bit the idea. The idea is to look for, you know, like the example that Ingrid showed about the beekeeping. The idea will be to make something similar. I mean, I want to do something in this area, some specific land use, and I need to find areas that have woodland. These woodlands need to be far away from the road, more than 500 meters. And I also need to be close to the water. So I need to be less than 750 meters from a river or a lake. For example, if I want to do a suitability map or to find which are the places in this basin that I can do this type of land use, and these are my restrictions, this is what we are going to do now. Very quick, because I think I'm running out of time. So the first thing we say is we need to have woodland. So we have a land cover map and we have woodland here in green. So remember, we say we have a database. So usually in GIS, there are many ways of doing the same thing. For woodlands, I will just come to the database. And here I can filter. I'm seeing all the 21,000 features. and I have 0 selected. But I can come here and I put a filter on a field. So if I open a filter and I choose the land use name, here I can start running woodland. So here is woodland. Oops. Here is a woodland. And if I press OK, I will get, as you can see here in this look name, all of the features I'm seeing, they are from woodland. So I have filtered from the 21,000 units. I have only 213 in this table. The ones that are land use woodland. So I can do something very simple. I can just come here to the edge and select every feature on this table. So here I have selected 213 features. So every feature is with woodland. Now if I come to the map, I'm sorry, here you see all the woodlands are now yellow because I have selected all my woodlands. So now that all my woodlands are selected, I can come here where say I as my land cover and export. And I can create a new shapefile. So here I am in my layer. I as land cover. I will just call this I as woodland. So I can create a new shapefile and I can use this option here, say save only selected features. Because I only selected the woodland, when I create my new shapefile, you see it's already been opened. I'm sure it will appear soon here also in my folder. I have a new feature called I as woodland that only contains, if I go to the attribute table, it only contains 213 features, which are my woodlands. So I make a new shapefile only with my woodlands, because these are my areas of interest for this exercise. So let me just turn this off aside. Now I have another requirement that was 750 meters away from the water, sorry, close to the water, less than 550 meters. This information is also in land cover. The land cover has information about the water, some of the rivers and some of the lake. So I can also take the information from there. But I can do a different way this time. Instead of building a new shapefile, what I can do is to filter this shapefile here. The first thing I will do is to unselect everything. So this is, the button is to deselect everything. Now you see my woodlands are already green. And this is another approach at filtering. I can go to the layer and I can open here this option, filter. And this will give me the query builder. Query builder, I can just select using the database anything I want. So I'm focused on land use name. And here I can say, okay, show me which are all the possibilities from land use name. So here I have water bodies. I want water, so I will put land use names equal to water bodies. And I also have another one here, which is natural water bodies flowing. These are the rivers. So if this is a water body standing, or if it's water equals to natural water bodies, I'm interested in those places. Then I say, okay. Oops. I don't know why it's taking so long. Let me see. Okay. So here, as you can see now, my land cover only shows me these features I have selected. Doesn't show any other land cover. And if I go to the attribute table, the attribute table only will contain these features. So it's almost the same as if I created a new one, because every operation I do now with this land cover will only be done on these features that you can see. The other features, the ones that are from other land covers that are, because I have this filter, will not be processed. So here I can run one of the tools that I need to define the 750 meters range. This is the geoprocessing tool. I have this tool here called buffer. So what I can do here now is take my IAS land cover, and here in distance I will put 750 meters. I have also here an option that means dissolve. I will click this one, and I will show you what it does. And I can save this to a file. This will be my water buffer. $750. And run. Okay, this is what I get now. If I overlay this will be showing me which are these areas that are closer to 750. I can put here my land cover. So this buffer is 750 meters from any water source, and this in brown are my forests. So here I can see where I have a coincidence between these two criteria. Why did I click dissolve? Because as you can see, there were a lot of different elements in this land cover. So this was one element, this one was element. If I don't use dissolve, it will make just a polygon 750 meters around of each of the features will be a single different feature. But because I put dissolve, every boundary in between these two is eliminated. And now, for example, if I come here to my water buffer and I select this one, you see this is a single huge polygon where everything is connected. And in this case, it was better like that. So I have the first two elements. I have the water, the 750, and my forest. What I can do next, I can come here to the vector. Here you see there are most of the, not most, but the common QGIS tools for vectors. As I mentioned before, here is a huge processing toolbox with a lot of vector tools to complement this one. But this is easier for this example because it has different small drawings that will tell you what this tool does. What I want to do here is clearly this one, intersection. So where these two layers meet. So I have the water buffer and the woodland. I want to see where these two are together. I will save this to a file and I will put this wood and water. Okay, run. Let me put it on top. Okay, and now we see In this red color are all the areas. If I turn off the other ones, I already created a shapefile where I have this thing. Areas that have woodlands and are closer to the water by 750 meters. I have yet another criteria that they need to be far away from the road, because what I'm going to do doesn't require to be close to the roads. Maybe the roads are too stressful for the animals I'm going to take there. So I have my roads here.
I think we can skip this because we are running out of time.
Okay.
And finish with only two criteria and maybe show the plugins.
Okay. So here, just to mention, it will be the same. To the rows, you can make a buffer, and then you can remove these areas that are 500 meters. Here in the vector, you have all these different possibilities. You can use the union, so where two layers meet. You can use the difference. For example, where the roads are, just take this piece out. This is the one you will have to use. So you can make it manually like this, for example, to make a suitability map, or you can also do different plugins. Here, for example, there is something in plugins. You have the plugin manager. It will open this window here. And here I already made a search. I just put criteria, and you get different plugins that have been developed from different people that you can install and you can try. This is just pressing, for example, this is not installed. You can install and just run it. And here to show you too, also, there are some tutorials in QGIS webpage about multi-criteria overlay. Of course, you can do this. This is using all free data from the same places I got it from OpenStreetMap. And they convert it to raster, and they do the multi-criteria analysis in raster. So you can go using the raster different plugins. This is a raster plugin that was already there. Or you can use, for example, for vector, if you can also to the page of QGIS, you will have here a lot of information about every plugin. They have the code, so it's free, and you can also look at what the different methodology it is. Some plugins like this are also well documented. You have here a tutorial on how to run this plugin. These plugins work for vector, and it has different models that you can use to do multi-criteria assessment. What I just was doing here is just not a wall-to-wall approach. It's just to choose which are the areas. I only want to see these polygons, but you can use different methods like the one that we'll be keeping that Ingrid showed. You can get a whole map of the study area, and you can see, okay, which are the best places, which are the average places, and the worst places. So you can just keep a little bit, or you can do a wall-to-wall approach in vector or in raster, depending on which data you have. But there are different tools that you can use and different approaches. Yeah, so I will continue later with the raster and elevation. Ingrid, then I give the word back to you. I don't know if there are some questions from participants, or we do it at the end.
If there are any questions regarding this, maybe we can answer them now, or should we continue to work with the digital elevation models?
I think there's no question.
Okay. So if you let me share the screen, Cesar. Okay, so Cesar just showed you a little bit of how easy it is to work with QGIS. I strongly encourage you, if you're GIS users and you're working with other software, to take a look at QGIS. And, and well, he showed a very simple way to obtaining suitability maps for a specific use. And now, I will give a very brief presentation on an introduction on using satellite-derived data, and then Cesar will continue working with digital elevation models for IH basin. So remote sensing is a very broad term. Satellites are just one of the platforms by which we can obtain remote sense data. Remote sensing is defined as the acquisition of information without making a physical contact with the object. So I always bring an example from history, which is good to enlighten us. And in World War I, for example, they used pigeons with cameras to obtain pictures and information. And this is also a type of remote sensing. A remote sensing platform could be also a live one. In 1957, the first satellite was sent to space, which was the Sputnik. And nowadays we have so many satellites that are surrounding us and obtaining lots of information. I think it's good to keep up with all the information that is available, because it could be very useful and it's free. And well, there are different types of orbits of satellites, the geostationary, which go from west to east over the equator, and they keep the same direction and rate of the Earth, so they show always the same area. And also the polar orbits. This is an example of how they allow to map the whole world by polar orbiting our planet. And like this, we can obtain, for example, mosaics, which are composite, they come from the composition of several satellite images. Also, it's good to, especially if we're going to work with digital elevation models, I think it's good to remember that there are two different ways of obtaining information, two different types of sensors on board of satellites. Some are active and some are passive. Passive means that they, this is the example of passive, which the sun, the light from the sun is reflected, and that is what the sensor in the satellite captures. Active is the same satellite sends information, sends energy, and that is what it gets back. For example, at the radar wavelengths. So each sensor can obtain and measure the energy at different ranges of the spectrum. And this is what we call bands. You know, we have, depending on the wavelength, for example, the visible light is very, very narrow, as you can see. This is what we can see, but some satellites also see infrared, some sensors, and other portions of the electromagnetic spectrum. I will go quickly on this because it's just to give an idea. Different satellites have sensors that can perceive the information at different ranges of the, at different wavelengths of the electromagnetic spectrum. And here we can see what we call bands, depending on which area, which energy they are perceiving. So, and then we can mix these different bands and emphasize the information that we want to see. For example, if we can mix the red, the blue, and paint it in these colors, and the green. And here, for example, we can see easily see the land cover in this image. For example, we can see urban areas, we can see areas where vegetation is green or not. And this is a broad world to explore and to get information, and it's really good to, for example, for land cover. We can also measure changes in this, in time, changes in land cover. We can mix different bands to enhance vegetation, and this is what the vegetation indexes do, and we will go deeper on this on one of our webinars. NDVI, EVI, SAVI, there are many vegetation indexes with mix, for example, the red and the near infrared bands of the information, and we can see, for example, with many dates in a temporal resolution, we can see how vegetation is the productivity is increasing or is decreasing, and this is really good for land degradation, for monitoring and mapping land degradation. Also, we can use this information, satellite-derived information, to map soil salinity. We will not use this for IAS because we have the information from the soil sampling, but it is also a use. And also with the active satellites, we can model elevation and have digital elevation models. Well, this I already said, that remote sensing is a great tool for mapping land degradation. And well, digital elevation models can be produced not only by remote sensing information, but also by topographic service. They produce relief maps, and they can be represented as raster or as vector-based using the triangular irregular networks, but they are commonly used using remote sensing data and as raster layers. Oh, this picture shouldn't be there. I don't know why, but the shuttle radar topography mission, which was flown in 2000, we can gives information for a 90-meter resolution digital elevation model, and it was later a product at 30-meter resolution was launched, and it is free, and it is for almost the whole Earth. It can be downloaded from internet. Here we can see, for example, the 90-meter resolution DEM for IASH. Now Cesar will show you this with more detail, also the 30-meter resolution and a 5-meter resolution digital elevation model. And the great thing about this is that we do not only get elevation, we can derive many other variables, such as slope, which is, for example, a very important variable to measure and estimate the risk of erosion, for example, or for these suitability maps could be a very good variable to consider. You can derive aspect, whether it is facing north, south, east, or west or east, actually. There are also other topographic indexes that you don't even need to calculate them. You can download them directly from the internet. So I was very quick because we are running out of time, and I give back the floor to Cesar so that he can work on the digital elevation models of IASH basin and show you how to obtain all these derived data and how to, one of the good things, for example, I told you that we have 3 different digital elevation models for IASH. So which one do we use? What are how do we explore these digital elevation models? How do we see which is best, or which is, or if there are any problems in one of them? How do we obtain these variables derived from them using QGIS? Thank you.
Okay. So if there is a question about the last section or what English has said, just let me know.
We have 15 minutes or so, Cesar.
Okay, so I will try to make it quick. But anyway, questions are very welcome, so please just let me know, interrupt me if there is any. So here, are you already in my screen again? Okay, this is where we stop. Here I have already some DMs, like English show. This is the 90 meter, this is the 30, and this is a 5 meters. I can open this all together here, and we can perhaps explore a little bit. I will put the 5 on top, 30 and 90. Okay, now if we zoom a little bit, if we look from here, from the distance, the whole basin, if I turn on and off, you cannot see much of a difference between the 5, the 30, and the thing. But if we get closer, probably when we start coloring, we will be able to see the pixels, the pixel size. But just to give you an idea, we can just go to any of this and look with our inquiry tool. And what we will get is an English show. So for every pixel, I will just get an elevation. So basically this is a matrix, and every cell has only one value. Okay, so where are these different sources of elevation come? Okay, there are different places that you can download data. There is a lot of data available. As Ingrid say, you need to find what is there and then decide which one to use. Make a bit of a quality check and controls. Here is this Earth Explorer. All of these SRTM, this DM 90 meters and the 30 meters are coming from here. Then you have this ALOS. Let me turn off the video. Then you have here also, I'm not adding this to the example, but this is ALOS Pulsar, is another option, is a 12.5 meter resolution DEM. Here from CGR, there is also the source of the 90 meter DEM, Digital Elevation Database. This is also very easy. All of these are freely available, so you just need to find the button that says download data, like here, and then you can just click in the place you are, and you can get Esri ASCII or GeoDiff with the DEM from your area. This is one of the best. I mean, it's a 90 meters, but it's been around for many years, and it's really good. Then there are this combination. This is a new version of the Aster GDEM. This combines the Aster with the SRTM, and this is 30 meter resolution. Also is the newest product from NASA. And also we download a lot from Google Earth Engine. This is to connect with the next webinar. So here you have most of the same sources. So this is the 90 meter elevation product from CGR. You can also use it directly and process it in Google Earth Engine, and you can also download it from here. Just to show you that there are different possibilities. And the thing is that then you need to see, okay, depending on what your project is, the size of your study area, if you're working a national level, perhaps 90 meters is more than enough. If you're working in a smaller area, you may need some more resolution. So here I have to show you some basic tools. This also works in the same way that before. You can come to symbology, and there are perhaps different options, but you can also color the DM using different colors. You have a huge options on palette. You can go here, like very deep in, let me see, my screen is a bit big and I cannot see where the things are opening. Okay, here I have also some specific palette for topography. So there are a lot of options that you can put here just to make it look nice, and change the color and perhaps be a bit more descriptive. So here is color from 400 meters to 1,600 meters in this color range, from greens to browns and white. And perhaps here you can more easily see the pixels of these different products. I will compare them now. I already have a project, so I don't lose time putting color to all of these. Also, you can copy the style, and for example, I can quickly paste the style on these two. So now they all have the same style, and if I maybe zoom here, I can see the difference. I don't know if you can see between the 90-meter pixel and the 30-meter pixels, and here maybe is the difference between the 5-meter pixel. You see is much more smoother. And there are a lot of tools that you can use to manage and explore the DM. Most of the tools are here in raster. If you come to analysis, you will find here tools like a slope, which is to measure the slope, aspect, which shows you which where the orientation of the slopes are, if they are facing north, they are facing east, west. This is very important because sometimes the northern slope have a different humidity, a different evapotranspiration, and a different vegetation than the southern slopes. So it's a very important variable to compute. And also the hillshade. Hillshade is a rendering of the, I can quickly show you. So you can choose a light source, and it will simply create a layer containing lights and shadows, giving you this texture of like a 3D texture, and help you explore much better your DM. Now, just let me close this project, and I will open a new project. I already have calculated the slope, aspect, and all these variables for the different DEMs. So here is a 90-meter DEM. What did I do here? I just calculated, just give the same colors that I showed you before and added this hillshade. Here the only trick is if this is normal coloring, you will see this coloring, just the layer, the DM, because it's on top. But if I can put here in blending mode, if I put multiply, this is a special option where I can see the colors of these first layers, but also the texture or the color of the layer that is behind. And here behind is my hillshade that I just showed you before. So I can see a color version of my hillshade, which helps me better to understand where are the high places, where are the valleys. And here we can also compare, for example, this with the 30-meter resolution. You see, perhaps it's much better. Can you see if I put the 90 meters and the 30 meters, you can see a bit more of detail. And I can also add at the 5-meter resolution. So here we are at the edge, and you can see here in one side, the 5 meters DM, and here in the other side of the line, you can see the 30-meter resolution. So obviously, 5 meters is much better than 30 meters. This gives you the bigger the pixel size, this is the 90 meter, it gives you a smoother version. So But at the end, these are all models. So this is a raster model. You can build it, as Ingrid said, from different satellites, passive satellites, like different images from different angles, stereoscopy. You can use radar information, like the SRTM mission. You can use LiDAR, drones, different things in order to get these different DEMs. Of course, every DEM has the particularities. As you can see, the 5 meters allows you to see a lot of things that if you put the 90 meters, you will not. So this is very, very clear. That more resolution is better. But not always is the case. You can check different things. For example, here, I also calculated the slope. This is the slope of the 90-meter DEM. So here, darker places are flatter and whiter places have the slope, more slope. So if we put this back and I put my slope on top, perhaps we can see here at the edge of these mountains where the slope is going up, you see the lighter places where the slope is higher. And when you put the slope on the different maps, let me turn on the slope on all of these. So this is the slope of the 30 meters, and this is the slope of the 5 meters. One of the interesting things to see, I always check the slope, because in the slope you see a lot of different things about how this DEM was modeled. So as you can see here, there are a bit of, I don't know if you can notice, some strange lines here in the 90-meter resolution. Not many, but there are some. If you go to the 30-meter resolution and you zoom in, you will see some of these lines too, a bit more often. And if you go to the 5-meter resolution, here in the slope, and if you also zoom in, you will see also some straight lines, like here, different black lines, and also some white lines that appear to be kind of like contour lines. So because of this is always a different models, all of the models have issue, I mean, some kind of problems. And when you project these models, for example, this 90 meters DEM was produced or is distributed in a geographic information system, in a geographic coordinate. And if you want to project it into a flat area, you kind of you make some distortions in the map. And when you make this distortion, these kind of things happen. What is the implication of this? Well, it depends on what are you going to use your DEM for. What is the information that you are going to take? If you are going to do soil erosion and you have and the slope is very important, and you have these things, it perhaps affect your maps and give you some strange result that then you need to correct. So it's very good to explore the data first and see what happens. And for that, there is a very nice plugin here. It's called here, manage plugin. There are a lot of plugins that are profile tools. So if you put these profile tools, there are different plugins with different profile tools. This QProf is also a good plugin. And you can basically use any of these tools to make a profile. Let me see if I can find my profile plugin. It was here. Okay. I don't know why I cannot find it. Commercial.
We have 5 minutes to wrap up, Cesar, so that we can have questions.
Okay, good. Then I will see if I find it. It was the icon here, but it's not anymore. Okay. So you can use any of this profile to make a 3D, to make a line and to make a 3D of your study area and see how the profile of the different DMs and slope are distributed. But a good thing that you can do also to see how the DMs are behaving, the best thing that you can try, it's always to delineate watersheds. So there are some different tools to delineate watersheds that you can use. Here in your toolbox, you can search for watershed, and there is this watershed tool from GIS. You just simply put your elevation map, and for example, I already have it here. You can have a lot of information, but very interestingly, you can also have the river networks distribution, and you can basically put this on top of different maps. You can use, for example, I can use here a ping map. Let me get the Bing satellite. Okay. So I can put here a image from Bing, and I can see here with my basin where my river network is, and that gives you a pretty good idea if the DM is working well or if having a lot of errors. So you can see this is a 90-meter resolution DM. There are some rivers that you can see in the image, and for the resolution is very good. So the water is flowing the way it's supposed to flow, is following the river. So depending on the modeling you are doing, this can be a good option. And also here, I was preparing this also for the same 5-meter DM. These are the streams of the 5-meter DM. And you can see, for example, here, how these streams are following what you can see on the high resolution image below. So this gives you an indication on how good. There are some areas where some errors or some strange things are happening, but mostly you can see how this DM is behaving and is following what you can see in the image. I mean, where you see a river or where you see drainage lines in the fields, you can see that the model is also finding this as streams or places for the water to run just across the road. So this gives you a pretty good idea of how these different models are working. So it's really good to use this watershed tool and always try to delineate the river network, because it helps you understand if the product that you have is where is working good, where is accurate, where there are problems. Perhaps these areas are too flat, or have been a lot of issues here that make the model get some confusion, but it gives you a good idea of how things are working. And also other thing that Ingrid mentioned, different indexes. Basically, you can derive a slope, which is this one we saw. Also, a very useful is the aspect. So here we have the aspect derive into categories. So places that are looking to north are in green, to south are in yellow. So this also correlates sometimes very well with what you see in mountain regions, that when you have some slopes, the vegetation behaves different depending on the angle they are looking to the sun. So it's a very important variable, but then you can also derive another things like this one. This is a map of landforms. You can classify it if you are in a peak, if you are in a valley, if you are in a slope, if the slope is very intensive, or if the slope is just the upper part of the slope, the lower part of the slope. So there are a lot of different indexes. From here you can see this is an extract from Google Earth Engine where you can directly download these indexes, the landform, the Chile, which give you some idea of evapotranspiration, because it also looks at where depending on the angle that the slope is facing, if you will get more sun or less sun, and you can use to account for evapotranspiration, and topographic diversity index that could be related to soil erosion. And there are a lot of different possibilities, index like this that you can get from Google Earth Engine, but you can also use some tools in GIS. You have this very nice tool from GRASS, which called slope and aspect, that can give you also profile curvature and tangential curvatures and different derivatives of the slopes. And also Saga has another module that is called slope, aspect, and curvature, and you can choose from many different, these are the papers that describe different type of indexes that you can use when you have a DM to make maps for different variables and different use, if you are looking at erosion or different things. And here you can just put, if you put a slope, just to show you one more thing. So here are the different, these ones that I showed you before, the slope, aspect, and curvature. So these are from different software, GRASS and Saga, but they are already integrated all in QGIS. So if you have a DM, you can just come here, put your DM, and then you can choose which of these different methodologies you want to use and which index you want to calculate. So just to show you a quick overview, there are a lot of different tools ready and very easy to use with a DEM to delineate basin, to delineate streams, and to delineate or to calculate different indicators for digital elevation mapping. Okay, I will stop here. So there is time for questions. If there is any question.
Okay.
It was quite fast, very little time to show a lot of things.
Okay. Thank you Ingrid and Cesar. Thank you very much. And Mustafa Bey, sanırım sizin sorunuz vardı.
I think Mustafa has a question. I have a question. Well, I'd like to thank Caesar and Ingrid indeed for their very nice presentations, especially about the presentation on raster data. It was quick. So I wish we have more detailed presentation on the raster data. That was a piece of information that I wanted to share. The resolution of 5 meters, 30 meters, and 90 meters in relation to EM. When we look at their overlapping with the image, especially image data from 90 and 30, are not overlapping with the actual object, actual imagery, but 5 meters is better. But there are still significant mistakes in the 5 meters, but the mistakes might be occurring because of the development of the DEM. There might be maize, corn, for example, in a land, so the image only shows the top of the maze. That is why the mistake occurs. And or if there are lots of rocks in a mountain, so the image cannot go through under the rock. That is why some mistakes might occur. Do you, especially for the use of 5 meters EEM, do you have any suggestions in mind that you can give us so that we can make 5-meter resolution better, the EEM better? And you also showed the stream in 5-meter resolution. We saw some streams, some segments of the stream in the croplands, for example. This cannot be the truth. So there has to be a mistake. So do you have any analysis suggestion in your mind for us to compensate for these mistakes, to correct those mistakes in 5 meters? Thank you.
Okay, good. Yeah, one of the things I also here I wanted to show you. Here I found my profile tool. So here you can basically, let me just show you something. So this is the slope. Okay, at here. So here you can just put a DM and you will get this profile. So it's like a slice of an area. And this is nice because you can explore the difference between the different DM. Let me put the 5 meters here, and we can chat about it. Add layer. Wait, because I have increased the resolution, then I cannot see anything in my screen. Let me see here. If I can put this back here, okay. No, I think I make a mistake. Okay. No, I wanted to show you a better comparison with the 2 different DMs. I've been exploring this a little bit, and what you have here is that perhaps now I can. Okay. Now I can. It's true. If you check this DM, you can see there are a lot of issues, and sometimes there are some errors in the data, like here. And this, when you see this in the image below, this corresponds to some trees, and also you can see here some scales here. So when you check the 5 meter DM, and when you make a zoom, you see that there are like jumps. So you have a flat area and then go down, a flat area and then go down, and the model should be something like the black line, so something smooth. And this is, yeah, because of the origin of the data. Normally when you do a stereoscopy, or when you use images from different, with different view that come from satellite or drones, you need to do some processing in order to remove the trees and to remove these things. The thing you can do here with the, I mean, there are works you can do if you have the original data, perhaps process it in a different way. So you don't have this sort of things here, that they look like a terracing. There are some ways to removing trees, but always that you remove these trees, you have to, you produce a bit of artifacts. One of the methodology that I found, one that would work good for solving
az önceki
this type
aşağıda
of
direklerle
things.
alakalı bir yer vardı. Direklerin geçtiği bir alan var.
There was that one. There was this region with the pools. Well, that one actually. this is a mistake, that one. How we can really remove this mistake? How can we correct it? That is the question. I think that these are the electrical masts, electrical poles. How can we correct this mistake? This is a mistake.
Yeah, this you can probably mask, make a mask and make an interpolation. I think you should try, you can try something like that.
Bu görüntü esnasında
but you will change.
Yani bu görüntü esnasında bize bir sıkıntı elde etmiyor ama buradan
it is not creating a big problem, but when creating slope or we might come across important mistakes, but it's a some localized mistake. But sometimes we might encounter many mistakes at once. As you can see here, these are trees which are a mistake. If we cannot remove them, then there will be mistakes in the slopes that we generate. So in order to correct those mistakes, do you have any method in mind? They're not creating a big problem for the time being, but they may create a problem in the future. So any suggestions in your mind that you can make to us? There's not a well or something. There's not a pit or something in here. This is a mistake. That one also is a mistake.
Yes. Yeah, as you can see, this type of mistake is type of, these are hole. I haven't tested, but there is a tool here that you can use. It's called a pit or pit removal or filling gaps. It's a way of making sure that the DEM doesn't have any of these holes. Is this one? So this one is a kind of a filter that produces depressionless elevation layer. So if you model hydrology here, once the water gets into this hole, it will not be able to get out. So what this tool does is apply a filter and try to fill these holes with data. So it will probably solve some of the mistakes in the DEM. So some of the mistakes maybe are solvable with this type of filter.
Yani çok küçük problemleri çözüyor ama büyük problemlerde sıkıntı.
Well, I think it solves the small problems, but it may not solve the big problems. But still, says I thank you very much for this nice explanation.
Okay, there is also another way that you can do is you can put your DM into a TIN format. So you can make transform this DM into a mesh. This is a vector model. The triangulated irregular network, you can put it into that, and then you can convert it into raster again. So you will basically reduce the
Çözüm olmuyor yalnız, yani denedik onları.
We tried it, and it is not creating any solution. Unfortunately, not.
And you have the original data that created this DEM. So this DEM come from a stereoscopy images, or is it live? What is the original data?
Yine 5 metrelik dem var elimizde. Bu
We have this 5 meter DEM for Ayash, let's say, and this is the problem that we generally see in this. And in our land studies, in 30 meters DEM or 10 meters DEM that we create using a machinery come with mistakes. If you do not do manual correction, generally you see such mistakes. They say in the digital models as well. Well, you know, Turkish soil is quite rugged, full of slopes and rugged terrain. That is why the maps really come with lots of mistakes, generally large mistakes, unfortunately, and we don't know how to compensate for that.
Yeah. Yeah, it's complicated, but if you have the original data that originated this DM, this DM was created using I don't know, by the look of it, it was created
Burada
using
ağaçlıklar var
stereoscopic
mesela. Bunun
images.
yoğun olduğu zaman ciddi hatalar oluşuyor.
For
Yani bunu
example, you have some trees, it can be overlooked for the time being, but if the trees are so many, so intensive, then you cannot overlook it, because if the trees are so many in the agricultural land, then what to do? I don't know. We have to really make lots of effort in order to eliminate them.
Yes. Yes. No, I think you have these sort of things, the trees, then there are these gaps here, and then there are these contour lines here that when you draw a line, you can see here that this also pattern
o
of
az önce gösterilen elektrik direkleriydi. Elektrik direkleri
I think the
yoğun
previous ones were the power plant transmission lines, power plant transmission masts or something. So it also is creating lots of problems. They are called high voltage transmission lines, and I think that's what we see.
Okay, yes.
These are high voltage transmission lines of the power plants, energy power plants. They are not pits, they're not holes actually, they are otherwise, they are quite diverse. They're elevated things, they are the masts, electricity masts.
Yeah, one thing you can always do is to do a pit this fill gap in order to fill some gaps, and then you can use another filter to try to remove the error, but that will change the DM resolution. You will be passing from 5 meters, for example, if you go to 10 meters or 15 meters, you can remodel the dam at a higher resolution. In this type of remodeling, perhaps you can get rid of a lot of mistake, but you will also lose a lot of resolution, because instead of 5 meters, you will have 15 meters. So it's kind of a trade-off, but if you see, when you see the water lines, in many places the DM is quite good. It's really capturing the water and everything. But yeah, if you want, I can try a little bit. I will try in a little bit of place.
Bir model önerirseniz memnun olurum.
Some solution, and I will.
We would be more than glad if you can try it sometime. Try to solve this mistake.
But so you only have the DM. You don't have the data that originated the DM.
Sadece model var elimizde.
Just the model. No, not the original data. No.
Because with the original data, you probably can solve it more easily.
Tabii ki.
But
of course.
But if you don't have the original data and the model, yeah, you only can fix some things. You can fix, but normally when you fix something, you break another thing. So we have to be careful not to break anything.
Evet.
Okay, but I will try a little bit.
Indeed.
Yeah, thank you.
Tamam. Teşekkür ediyorum. Sağ olun. Sağ olun.
Thank you, Mustafa. Another question from the floor? No, I think not. Okay, in the absence of questions, I'd like to declare the session closed. Mrs. Sarah, would you like to say anything to wrap up the session, to close the session?
Thank you very much. No, just thanks for everyone's participation. I have nothing else to add.
O zaman ben de çok teşekkür ederim.
Okay then, thank you indeed, Ingrid and Cesar. Thank you for your nice presentations, and thank you all for the participation and contribution. And I'd like to thank our interpreters, Deniz and Kıyal, for their interpretation. And if you have any questions later for Cesar or Ingrid, you can always contact us and we can get your answers later. See you in the third webinar. Eileen, I'm sorry. Are we going to have access to the video recordings of today's webinar? Who are we going to approach for the video? My colleagues have already recorded the webinar, both in Turkish and English, and we will be sharing the link with you. Thank you very much for everything, for all the organization. Thank you. See you later. Bye.
Thank you. Thank you very much. See you in the next webinar.
Thank you for your time. Bye-bye.
Thank you, Denise and Kia.
Thank you.